For the second problem set, we're going to be looking at the actual rebar then in our entire foundation. If you look at the plans for Plan 100, it really only has very minimal reinforcing in its foundation. They use a keyway for tying the foundation wall to the footer and only two continuous rebar around the entire foundation. So we've decided to beef it up a little bit so we can actually understand all of the calculations typically required for reinforcing. So, in addition, or replacing what is already there, we have 3 number 5 continuous in 8 by 16 footer. So this is the back and sides. We have 4 number 5 continuous in the 12 by 24 footer. We have our number 5 ties spaced 24 inches on center around the entire footer. We have 2 quantity of number 4 dowels, 16 inches on center around the entire foundation. The dowels, each one is 2.5 inches, and then we also need to have them on both faces, so both sides of our wall. We have horizontal number 4 continuous, each face of the foundation wall at 16 inches on center. We have vertical ties, the entire foundation at 3 foot on center. We have our coverage, 3 inches on all sides of the rebar. Overlap is 30 bar diameter still. And we still have the 4x4 W2.9 by W2.9 welded wire fabric in the slab. So we use these last two on our previous sample problems, so we won't really be needing them for these calculations. So we're going to look at the different types. We'll focus first all on our number 5 rebar and get a total for that. And then we will focus all on our number 4 rebar and then have a total for that. If it's different, keep it separate. So that's why we're splitting between the number 4, our 1/2 inch, and the number 5, our 5/8 inch. When it comes to the application, we initially need to keep it separate in terms of the ties and the continuous, but ultimately we can add them all together when we're coming up with our final answer. And also in here, we're going to add 10% waste for overlap, so we don't have to worry about the bar diameters when we are dealing with our calculations. All right, so as we go through this, I'll refer back to the different types of rebar that we have. So number 8, we are looking at our number 5 continuous. So per our specs, the continuous rebar number 5s are going to be in our footers. Both footers, we just have different sizes for those depending on which one we're actually going to be working with. So if you recall, if we're looking at continuous rebar, if we look at it from a section view, we're only going to see it as dots. But if we're looking at it as a plan view, it is going to run around the entire foundation. So regardless whether it is a footer or a foundation wall, in the plan view, they will be running around the continuous. And then in the section view, they will be seen as dots. Here, we want to use our center line for our length. So even if this center one is the only true one at the center line, by taking the center line for all of them, we will eventually average out the different lengths and have the most accurate dimensions. Again, we don't want to use the outside perimeter, we don't want to use the inside perimeter. The center line is what is going to be the most accurate. So even though we have different quantities in our front wall versus our back and sides, we can still add it all together in one calculation. For our back and sides, this is where we have our 18 by 16 footer. In our front wall, we have our 12 by 24 footer. Per our specs, there are 3 continuous in our back and sides, but we have 4. We have an additional one because we have a little bit wider footer. We have 24 inches versus 16 inches. But we just need to match the correct centerline dimension with each one. Our back and sides, we calculated in the first problem set, was 86 foot 4 inches. And then our front was just our 35 foot 4 inches. So we can lump it all together in one calculation because it all is all number 5 continuous rebar. Gives us a total of 400.3 repeating, so roughly 401 lineal feet of number 5 continuous rebar. So next we're moving on to our ties. You can look and see what we're talking about when it comes to ties in our footer. In the section view, this is going to be just a straight line. If we look at a plan view, it's essentially the rungs of the ladder. They are going to be what tie our longitudinal or continuous rebar together. So at each connection, we would tie them together. So that is why they call them ties. We need to know a quantity, but in order to calculate that, we are given a spacing. So if our ties are 24 inches on center, just like our other repetitive member items, we can take our length divided by the spacing, but we want to make sure we add 1 per wall, similar to the studs that we did, because we don't have just one continuous wall. We have multiple walls in a foundation system. The length, make note, is determined by the coverage requirement. So if we have a 2 foot or 24 inch footer, it will not be a full 24 inches of tie. We have to account for the space that makes sure we cover the rebar with concrete so it does not get in contact with the ground and then rust out. So first off, we want to look at the lineal feet of each tie. So we're looking at a single tie. What is that length? So this is determined by our coverage. For our number 5, we're looking at our footers. It was given to us that we have 3-inch coverage on all sides. So if we have a 16-inch wide footer for our back and sides, we subtract 3 inches from each side, and we end up with 10 inches as the length of a single tie. In number 10, what we can then calculate is our total lineal footage by calculating the quantity of each one. So if we take, again, this is our back and sides, we have our 86 foot 4 inches is our center line perimeter for the back and sides. We can divide this by our 24-inch tie spacing, and we end up with 43.1667, which we round up, and we have 44 spaces. Remember, we need to add 1 per wall. And since we have a back and 2 sides, we have 3 walls total. So if we take 44 plus 3, we end up with 47 ties. So these 47 ties are all 10 inches in length. We just determined that in our previous number 9. Make sure you convert to feet, and we end up with 39.166, or I've just rounded it to 39.2 feet. So this is the total lineal footage needed for all of our ties, and then we can cut them down. We also have ties that are in the front, and this is a 24-inch footer. Remember, for our front wall, it is a different width of footer. It still has the same coverage, however. So when we subtract those out, we end up with 18 inches for each one of our front wall ties. They're still spaced 24 inches on center. They're just going to be a little bit longer because we have a wider footer. And if you recall, we had 3 of our continuous in the back and sides, but there's 4 in our front. So they need to be a little bit longer to tie all of those together. From that, then, we can calculate what our full quantity of, full lineal foot of ties are based on our quantity. So we take our 35'4" center line length of our front wall. So again, we're still dealing with the front. Divide it by the 24-inch tie spacing. So it just said that in the specs that the tie spacing is 24 inches on center entire footer or entire foundation system. So we did not have to specify in this requirement whether it was front or back and sides. It can be the same for all. We get 17.66, round up to 18 spaces. Here we're only dealing with the front, so we only have one wall that we are dealing with. So we end up with 19 ties. All 19 ties are 18 inches. So if we convert that into feet and account for the quantity, we get 28.5 feet for our number 5 ties. For 13, then, we're totaling up all of the number 5 rebar. We converted everything, all the different types, into a linear footage so we can add them all together. So our total is going to be 400.3 repeating for our continuous rebar in our footer. We have 39.167 for our 8x16 footers. Those are the ties. And we have 28.5 feet, those are all feet, for our 12x24 footers. Again, these are ties. Gives us a total of 468 feet for our number 5 rebar. We need to convert it into weight because we purchase in terms of weight. Again, we need to look at a chart from the PowerPoint. You could look it up if you want. We just need to figure out what the weight per foot, so pound per foot, for number 5 rebar is. If we look it up in the chart or Google it to find out our answer, we see that it is 1.043 pounds per foot. So we can take our 468, multiply it by 1.043 pounds per foot, and we end up with 488.124 pounds. We aren't quite done yet because we need to add 10% of waste that was given to us in the problem. So we can take our 488.124, multiply that by 1 plus our percentage. 10% is 0.1 in decimal form, and we get 536.9364, or 537 pounds for our rebar, number 5 rebar. So now that we have calculated all of our number 5 rebar, we want to look at all of our number 4 rebar. So if we're looking at all of our number 4 rebar, we essentially need to go through all of the same steps. Look at continuous, look at ties, look at dowels, because we have dowels in this scenario. If we look back at our sample problem, we have number 4 dowels. We have horizontal number 4 continuous in our foundation wall and vertical number 4 ties in our foundation wall. So we have 3 different areas that we need to calculate for our sample problem. So number 14, we are looking at our dowels. There are different ways to tie our foundation wall to our footer. Dowels, hooks, stirrups, there's different ways they are going to be termed. Dowels and hooks, depending again how they look, it can help determine. If it's a stirrup, usually it's a U shape. It goes, down and up like a typical stirrup would. But we calculate the same as ties. We have a spacing requirement that we have to figure out a quantity for, and then we either need to calculate what the length is of our dowels, or we can see what's given to us. Typically, you will have either one that will tie the foundation wall to the footer, or you might have two. One on both faces or both sides that then tie in to the vertical ties on our foundation wall. So in our sample problem, we do have both sides. So we need to make sure that we account for both when we're doing our calculation. So starting off, we're going to look at our dowels. We are told that each dowel is 2.5 feet in length. So this is not a pair of dowels. This is one dowel only, is 2.5 feet. Our requirement that is given to us is that for the entire footer, they are spaced 16 inches on center. So it doesn't matter whether we have an 8-inch wall or a 12-inch wall, they will be the same. The only difference that will occur is that the spacing between the dowels, the vertical portion of the dowels, will be closer together on the 8-inch wall than they are on the 12-inch wall. But it doesn't matter the thickness, the requirements will be the same all the way around. So that means we can use our 121 foot 8-inch center line, that is our entire foundation system, rather than breaking it up between the front and the back and sides. We divide it by our 16-inch on center dowel spacing that is given, and we end up with 91.25, rounded up to 92 spaces. Just like with the ties, we need to add one per wall. We have our entire foundation system, so we have 4 walls. So 92 spaces plus our 4 walls gives us 96 dowels times 2 for each face, or each side, however you want to look at it. Remember, we have what we just calculated by finding the 96, that's only one of our dowels. We have the other one on the other side or the other face of our wall, so we need to multiply it by 2. That gives us a total of 192 dowels for our foundation system. The 192 dowels are each 2.5 feet in length, so we get 480 feet as the total lineal footage of our number 4 dowels. For 15, we're looking at our continuous. Now, the difference with continuous in the walls is that they're typically going to be multiple rows. So in our footer, they just go straight across, and we are given a quantity by how many there are. But with our continuous walls, we need to look at how many there are going to be. We have, again, in the section drawing, they're going to be shown as dots, but if we're given a spacing requirement, this spacing requirement is the vertical dimension, or the vertical spacing between the rows of continuous rebar. So we can use our centerline length. We might need to calculate the quantity using our spacing requirement if it's not given to us, And again, you might have the the continuous rebar on both faces, just like we had the dowels on both spaces. So a note that might say number 4 at 16 inches on center, talking about the continuous rebar, again, that spacing, the 16 on center, is the vertical spacing between the continuous rebar. So if we're looking for our quantity, we take the height of our foundation wall, which equals 8 feet. We divide that by the 16-inch on center, and this is our continuous spacing, so continuous rebar spacing, gives us 6 spaces. We add 1 to close out the ladder, and then we would end up with 7. But again, we want to make sure that we are accounting for both sides, so we need to make sure that we multiply it by 2 for both sides or both faces. So total, we have 14 continuous rows, or essentially 7 rows, but 14 continuous rebar. Given that, we can take our center line, because it is the entire foundation, which was 121 feet 8 inches. We can multiply that by the quantity we have, and we end up with 1703.333, repeating, so roughly 1704 lineal foot of number 4 continuous rebar in our foundation walls. Just like with the dowels, it doesn't matter that it is a 12-inch wall or an 8-inch wall. The rows will simply be closer together on the the less thick walls than on the 12-inch walls, but we can still use the same center line for the entire thing. We don't need to break it up between the front wall and the back and sides. So once we have our continuous, we can look now at our ties in our foundation walls. So when we are dealing with ties, we are in a section view looking at them as a straight line. So just like when we had the ties here, same thing, straight line. And then instead of looking like a rung of a ladder, they're actually going to look like little dots if you're looking down from above. But it is calculated very much the same way. We have to look at the coverage to determine the length requirement, and we have to calculate quantity based on our spacing. And it will have typically on both faces, depending on how your foundation is set up. So for this one, it's just a quick view on our calculation or quick drawing. The vertical ties, that is what we're calculating, and it's what ties these dots for our continuous together around our foundation. The coverage, remember, is what helps determine our length. The coverage for all of our foundation was specified at 3 inches. So if we have 3 inches required at the top and 3 inches required at the bottom, we can take our 8 feet for our foundation wall height, subtract out the 3 inches on either side, and we get 7 foot 6 inches is going to be the length of each one of our ties around our foundation system. We can use our entire center line to help determine what our quantity is, our 121 foot 8 inches. That's our center line, divided by the 3 foot tie spacing given. So in our specifications, we were told that the vertical ties are 3 foot on center. So there's a lot more spacing between these as we go around our foundation. This gives us a total of 40.556. Again, round up, we have 41 spaces. We want to add 1 per wall, so we add 4 because we are using our entire foundation, all 4 walls. So we end up with 45 ties on each face or each side, however you want to look at it. So if we take our 45 ties, multiply it by 2 to get both faces, we end up with 90 total vertical ties that are all 7 feet 6 inches in length. So we end up with a total of 675 lineal feet of number 4 ties. So now we come up with our total. This is actually number 18. I apologize. Number 17 starts here with calculating the total lineal foot. Number 16, the 7.5 foot length for each of the ties is the final answer. So number 17 is calculating the total lineal footage. So 18 then is totaling up all of the different number 4 rebar. So our total comes from the 480 lineal foot of dowels, from the 1703.3 repeating of our continuous horizontal ties, our horizontal continuous, and then the 675 feet from our vertical ties. 2858.3 repeating. Looking at a chart, we can see that for number 4 rebar, it is 0.668 pounds per foot. We can multiply that by our 2858.33 feet and get 1909.367, and that is in pounds. But just like with our number 5 rebar, we want to add 10% waste. So we take our 1909.367 pounds and add 1, I apologize, we multiply by 1 plus the 0.1 or the 10% to get 2100.303 or 2100 or 2101 pounds. So just over a ton of number 4 rebar for our foundation wall. So it can be very confusing to truly understand all of the different types. So we just want to review those really quickly. If we are looking at our dowels, again, they can come in different types. They can either be as an L shape. They could also come as a U shape, meaning as a stirrup that goes down into the footer and back up. When it comes to our continuous rebar, so both the foundation wall and the footer, continuous will be seen as dots along the sides and then dots along the footer. If a spacing requirement is given, it is going to be in between each of those rebar. And then for the ties, they can either be vertical or horizontal. So they can be on both sides of the face when it comes to the foundation walls. So what is important here is the coverage. And what the coverage does is ensure that we don't get any water in contact from the ground with the rebar to cause it to rust. So that's just a quick reiteration. All of the plans or the drawings that have been provided are on Blackboard for your reference, and that concludes how to calculate the reinforcing for Plan 100.